Hi. So the question is, we're going to be given a function, and then in a quantum circuit, that function is going to act as a control for flipping our target qubit. So it's going to leave the control qubit alone as it passes through this gate, and then it's going to change my target qubit y according to whether f is 0 or 1. Now, the idea of Deutsch's algorithm is that we don't need to know what this function is, and we can still figure out whether it's balanced or constant, just faster than classical stuff too. So here, what about f of x equals x? In the textbook basis, we're going in like lexicographical order, starting by just what is x and exhausting the possibilities for other stuff, and then go on to the next value of x. In the Qiskit basis, we're talking about, we want to list these numbers as if we were reading them off in binary, with the x being like your 2 to the 0, your 1's place. So it goes 0, 1, 2, 3. So 1, 1 is 3 in binary, so we'd want that one to be the last one. And that's how Qiskit likes to order theirs. So they're going to get whatever matrix you get from the textbook basis is going to look different in the Qiskit basis. We will see. Okay. So first off, let's just say, what is f of x? F of x is just equal to x here. So we're just repeating what x is. Now, what is y plus f of x? This, we're just adding these two columns, the y and the f of x column, and we're going to reduce by modulo 2. So here we're going to get 0 plus 0 is 0 mod 2. That means if I start with an even number and I add an even number to it, I get an even number. 1 plus 0 is 1. If I start with an odd number, add an even, I get odd. Even plus odd is odd. Even, or odd plus odd is even. So this is like an adder, but we're only taking the remainders from whatever we get. We add these two, take the remainder. Okay. Now for the x bit, it's the control bit, so it stays the same as whatever we input to it. Our target bit is going to change to this green column. So now if we input off for both of our qubits, we're going to get off off. So we get a 1 here. This vector, this column vector is just the 1 in the 0, 0 place. If we input 0, 1, we get 0, 1. So we're going to get a 1 along the diagonal there. If we input a 1, 0, we get a 1, 1. So with this 1, 0 column, we get a 1 down here. And then if we input 1, 1, we get 1, 0. The 1, 0 right here. Okay. That's all the time we have for this answer. Okay, bye.